Welcome to SPC Insights with Dr. Bill, simplifying SPC and statistical analysis. We're going to take a look in this video at control charts and global warming. Was 2022 the hottest year ever recorded? Where does the data come from and how's the global temperature deviation calculated? What's the baseline data we use in the calculations? When did global warming start? Is the increase in global temperature deviations predictable? And how can control charts be used to monitor those deviations? What do they tell us about those deviations over time? No, 2022 was not the hottest. 2020 was the hottest ever recorded. Here you see a chart of the annual global temperature deviations over time. About 1880 to about 1940, things were pretty consistent. Same is true from then up to about 1977. And then in 1977, things began to move up quickly. And you can see the last 8 years have been the hottest ever recorded, at least since 1880. So where does the data come from? It comes from the Goddard Institute of Space Studies. They're part of NASA. It's the Land Ocean Temperature Index is what it's called. And it gives the global mean monthly, seasonal, and annual from 1880 to the present, that deviation. So the downloaded data is in the format where it gives you the year, the month, and the deviation. That global temperature deviation. The deviation is the difference between the temperature reported and the temperature for the baseline period of 1951 to 1980. So you get data that looks like this. The best estimate of the global mean for that time was 14 degrees centigrade. So if you're 14.5 degrees centigrade 1 month, then your deviation is 0.5. So each month's deviation is calculated, and then we simply take the average of those deviations to find out what the yearly global temperature deviation is. Here's the data for 2022. You average those deviations and you get 0.89, which means in 2022, the global temperature was 0.89 above what it was in the baseline period. So we're calculating here the annual temperature, again, the annual global temperature deviations. It looks where it starts to trend up. It's about 1977, and that's really when global warming appears to have started. So how can control charts help analyze global warming? So we need to remember about control charts. You're plotting data over time. You calculated an average and control limits. It's going to tell us if the process is consistent and predictable, and it's going to signal when there's a process change. Well, let's take a look when we apply control charts to the baseline period to start with. And here's the baseline data from 1951 to 1980 as a control chart. It's in control, no points beyond the limits, no patterns, it's consistent and predictable. The average is 0. Since you're using this as the baseline period, you'd expect those deviations to go to 0. There's 1 point near the end, which is pretty close to being out of control, but basically it's in statistical control. The question is, are there other stable periods for global temperature deviations? The baseline data was stable. Yeah, there are others stable prior to the upward trend in global temperature, and you can find these by looking at the chart and splitting the control limits between those stable periods. So there are 5 stable periods which you can show here. From 1880 to 1902 was one with an average of minus 0.21. Then from 1903 to 1913, and 1914 to 1936 was the third. And then here's 1937 to 1976. And then finally a fifth one was a short, 1977 to 1986. And then things begin to take off and go on an upward trend. So what about the trend since 1987? You can use a trend control chart actually to analyze these. And what a trend control chart does is it puts in a regression and best fit line, and if it is an upward trend in the data, if it's significant, then you can use a trend control chart. And that's shown here from the data from 1987 to 2022. And you can see that that process looks like it's in control. No points beyond the control limits. There's the annual temperature deviation. It's changing by 0.02 essentially each year. You can use it to predict the results in 2023. We predict it will be a deviation of 0.968, which is just extending that center line 1 more year. So can you look at this data though differently? Because people say, well, yeah, definitely there's an upward trend in it, but let's take a look and say, can you look at it differently? And you can. Here's the data plotted since 1987, same data going up, but let's take a look and see if there's a different way we can look at it. For example, there's a period at the start of the data which appears to be fairly stable. 1987 up to about the year 2000. Then there's another one from 2001 up to about 2012, 2014, and there's actually a third one So, is it possible instead of a trend that this data is actually a series of step changes upward? So you can take a look at it and use the control limits and control charts to do that. There's a period of 15 years starting in 1987 that appears to be fairly stable. Then there's a step change up in around 2001, and there's a period of 13 years where it's fairly stable. And then the last 8 years appear to be fairly stable. So you can take that trend and begin to say, okay, can we look at these as a series of step changes? And you can see that it definitely appears to be valid. So conclusions in terms of global warming. The global temperature is increasing over time since '87. It is not a constant upward trend. The last 8 years are stable, but this pattern's repeated itself over and over. The two previous patterns. So there's a period where they're stable and then a step change upward, and there's no reason to expect that to change anytime soon. So here again is a picture of the global temperature deviations from 1880 up to 2020, and here it is now with the step changes in looking at it instead of a trend at the end, a series of step changes. So thank you very much for watching the video. Click on the YouTube button to subscribe to our videos. Come to our SPC Knowledge Base for 220 free articles. Make your own charts using our software. Thank you again for watching the video.